questions. All right, guys, these functions right here, all right, you can put functions together, add, subtract, multiply, and divide the entire thing. Now, it looks like f of x equals this, which is a quadratic function, and g of x equals this, which is a linear, it is a binomial, but it's a linear function, right? So this is going to make a u, this is going to make a line, but you can actually add a u and a line together. You can subtract them, you can multiply them and divide them, you can do all those things. What is new for us is not how to do it, it's how to write it. This right here means the function f plus the function g. That's what f plus g parentheses x means, all right? It means add the two functions together. It is not a variable f plus a variable g, and then you multiply those together and get an x. That's not what it means. It is the function f plus the function g. Now, I know you know how to do that, so let's do it. I'm going to, what is my function f? 2x squared plus x minus 1. And what is my function g? 2x plus 1. And what am I going to do with those? Add them together. Does this sound simple enough? I hope that it is. The only thing I would caution you about is, are you adding a 2x or are you adding both the 2x and the 1? You're adding this entire function g, right? So just to be in a good habit, I want to make sure I recognize that I'm adding both of those together. Now for this one, it really don't make a difference, but it will in the future. So, this is just polynomials. How do you add them together? Like terms. So this is just like we did earlier. So I've got x and x, those are like terms. I got -1 and +1, those are like terms. So when you clean all that up, you find out that f plus g of x is equal to 2x squared plus 3x plus 0, right? Okay, and that's it. Now, why do I care to do that? Well, because it actually simplifies computations when I'm looking in my calculator. And I am going to go to the calculator now, so you guys won't be able to see this on the screen. But I'm going to go to the calculator now. We're going to investigate this. So I want you to put f of x in y1, and I want you to put g of x in y2, and I'll show you what that looks like up here on the board. Alright, so now I'm at subtract. So of course it means to do exactly what you think it means to do. You're going to do 2x squared plus x minus 1, and over here is 2x plus 1, and you're going to subtract them. And again, I ask you, what is it that you're subtracting? The entire function, g. So is this okay? No, I have to use parentheses, otherwise I will forget to subtract 1. So it's very important that you have the parentheses there. So you clean that up, you look for your like terms, and that gives us 2x squared. Let's see, I've got an x and a minus 2x, so that's minus x. And -1 minus another one is minus 2, is that right? So here's my new function, f minus g of x is equal to 2x squared minus x minus 2. We'll go to the calculator and check it. Alright, you should not be surprised at all that you're going to multiply here. So I've got to do 2x squared plus x minus 1, and I'm going to multiply that times 2x plus 1. Now I do have a question for you. We talked about this at the beginning of class. How do you multiply these? Okay, you're going to have to distribute both terms in the binomial to all three terms in the trinomial. You could say it's exactly like a FOIL problem. Technically, it's not a FOIL, but it's the exact same process. Okay? I'm going to show you two ways to multiply it because most of you know how to do this, but I want to show you two ways of doing it in case you get mixed up. Okay? I personally would take the binomial to the trinomial instead of the tri to the bi, but it doesn't matter. So I'm going to take the 2 times all 3 of these. That's just the distributive property, right? And then I'm going to take the 1 times all 3 of these. And I have multiplied every number together. So what does that look like? One at a time. 2x times 2x squared. All right, that is 4x cubed. And then I have 2x times x. It's 2x squared. And then I have 2x times negative 1, which is minus 2x. I have used all three of these, so now I'm going to go to the 1. 1 times 2x squared is plus 2x squared. I've got 1 times x, which is 1x. And I have 1 times negative 1, which is negative 1. Now what do? Clean up your like terms. You got any? Here's 2. And here's 2. So I think you do have some like terms, so just put them together. And it looks like my answer should be 4x to the third plus 4x squared minus 1x. Somebody double check me there. And then minus 1. Is that right?
Yeah.
Okay. So that would be f times g of x. Okay? Now, if you want to see a different way of multiplying that, I'll be glad to show you. This is the least amount of paper way. And I know how you guys like to save paper. I like to get it correct. So I want to back off and just remind you of this on how to multiply. If I would have asked you to multiply 238 times 42, what would every single one of you have done? What would you have done with this 42? You'd have put it down here? Is that right? Every single one of you would have moved it to here, drawn a line, and multiplied it horizontally instead of, vertically instead of horizontally, right? Because that's the way you've done this for years and years and years. And then you would have done, I'm going to do the whole thing. 2 times 8, 16, carry, 2 times 3, 6, 7, 2 times 2 is 4. What would you do after that? What do you do here? 0, right? Because technically you're not really even multiplying by 2, you're actually multiplying by 40. So you put the 0 right there. 4 times 8 is 32, carry. 4 times 3 is 12, 15, carry. 4 times 2, 9. And then you add. Is that correct? So I'm just showing off my wonderful, wonderful mathematics skills. Is this the way that every one of you would feel comfortable multiplying? Is there any reason that this problem is the same? Is there any difference between this problem and this problem? 2x to the third plus x minus 1. Okay, I'll fix that. 2x squared. Times, where is it? 2x plus 1. Aren't these the same? Yeah, they're the same. What did you do with the 2? Multiplied it times all 3 of those. What are you going to do with this 1? Multiply it times all 3. So that's going to give you a 1 here. A negative 1 and a positive x and a 2x squared. Right? And then what do you do on the second row? Always add a 0. And now you're going to do 2x times this and 2x. Is there any difference? I hope you recognize that there's not a difference. It's the same process as you learned your long multiplication, right? And then what do you do with all those? Add them together. So that's a negative 1 and a negative 1x and a 4x squared and a 4x to the third. That was positive. Is it the same answer? Okay. So I just wanted to point that out to you that it's the same. Do it. I don't care which way you do it. It's the same. Okay? Let me erase that. I'll get rid of it. So here's what we're going to look at to start with. I am going to divide. It's f divided by g, so which one goes in the house?
G.
Not correct.
No, wait, G's on the outside.
G's on the outside. G is the divisor. So f goes in the house. So I've got 2x squared plus x minus 1. We did this last week, right? You had a whole test on it. I'm going to divide it by g, which is 2x plus 1. Looks a little crazy, but it's actually very doable. how do I figure this out here? How many times will 2x go into 2x squared?
X.
Okay, so that's just an x. And then I multiply x times both of those, and I get 2x squared plus x. What are you going to do at that point? Subtract these. This, by the way, on your test was probably the number one mistake in your division, was you did not subtract the second term. You would subtract the first terms, but you would forget to subtract the second terms. You would accidentally add them. So anyways, I've got 2x squared minus 2x squared. That goes away. What about x minus x? By coincidence, that one also goes away, doesn't it? Normally that doesn't happen, but it did in this case. So I can say 0x, and then you would bring down the negative 1. That should be in blue. You'd bring down the negative 1. Now that's really not there, is it? Okay. How many times does 2x go into negative 1? It doesn't. So this is my remainder, isn't it? So this is plus, or actually it's minus 1 over 2x plus 1. So my function, that's my function. My function, f over g of x, is this function right here, x minus 1 over 2x plus 1. Now that is super weird. So we're going to go to the calculator and look at it for a minute. We also need to talk about up here. Actually, let's talk about that before we go to the calculator. This function is only defined as long as g is not 0. Because I'm not allowed to divide by 0, right? So what is g again? G was a function 2x plus 1. So what I'm going to do is I'm going to go check that out. I'm going to say, hey, wait, g is the function 2x plus 1. So instead of me saying that g cannot be 0, I'm going to say 2x plus 1 cannot be 0. Now, I don't know about you, but that looks a whole lot like an equation. It's actually an in equation. It's a not equation. But I can solve it exactly the same. If 2x plus 1 cannot be 0, then guess what? 2x cannot be negative 1, can it? And if 2x does not equal negative 1, then x cannot equal what? Negative 1/2. And that's where I want to go. I want to go look at the calculator and I want to see why that can't be true. So we're going to take a time out here. We're going to identify this as actually being our domain. That this is the function, but only when the domain is x not equal to negative 1. We're used to writing that x could be all real numbers, right? This time I'm telling you it can be any number in the world except negative 1/2. I think I said 1, but negative 1/2. Okay? And that's how you would write that. So this is what I'm looking for you guys to do. All right. You've got 4 problems.